Hey everyone, welcome back to the channel Code with AKJ. Today is day 19 of solving GeeksforGeeks problem of the day. Today's question is minimum number of deletions and insertions. The question says given two strings, string 1, string 2, the task is to remove or insert the minimum number of characters from string 1 so as to transform it into string 2. So it could be possible that the same characters need to be removed or deleted from one point of string 1 and inserted to some another point. So given example here is string 1 is heap and string 2 is p. So let's understand this. String 1 is heap. So by analyzing these two strings, we can see that we can delete h from the string 1 and ea remains same, and we can delete p also, and finally we can insert this p at the starting of the string s1. In this way, we can convert string 1 into string 2. So from the example we have discussed earlier, we can simply observe that we need to find a common subsequence from both these two strings, and finally we deduct this particular length of the common subsequence from the length of these two strings, and we'll add the remaining unmatched characters, and this would be our number of insertions or deletions required. So finally the task would be to find the longest common subsequence of these two strings and deduct the length of common subsequence from both these two lengths, and finally add these two values into our answer. So let's dry run this bit. So here I've drawn the recursive tree and how this longest common subsequence works. So I've taken these two strings and two pointers here. So we'll compare the characters of these two strings. If they don't match, we'll recursively call by moving pointers I plus 1 and j plus 1 separately, and if they match, we'll add a value 1 and we'll recursively call the function by moving I plus 1 and j plus 1 parallelly. This would be the condition if they match, and there would be two separate calls. By one would be by moving I pointer forward and making j pointer as similar, and one call would be making I as constant and moving j pointer as forward. So and we'll take the maximum of these two calls in the case of not matching any character, and we'll add a value 1 as the particular characters are being matched. So in this way, I've drawn the recursive tree. Since here h and p are not matching, so we'll do the recursive call j plus 1 and I plus 1, and again it will give a recursive call. Here I would be at e and j would be at p itself. Since they don't match, we'll again give a recursive call to I plus 1 and j plus 1 moving forward, and here I would be at A, J would be at P, and here I would be at E and J would be at E. So in this case, since these two characters are matching, we'll add a value 1 and we'll move I and J parallelly. So in the next case, I would be at A and J would be at A, and since these two characters are matching, we'll again move forward, and again these two characters are being matching, so finally we'll move I and J pointers forward. So since here j is out of the string, so this would be our base case. If any of the indices goes out of the string's length, we'll return 0, as there would be no characters being matched here. So we'll return 0 here. So value would be 1 plus 0 1. We'll return 1 from this particular call, and again 1 plus 1 would be 2, so we'll return 2 from here. So again it goes on till the main case. So when it comes to the j plus 1 case, same recursive calls takes place, and from this particular call it returns 0, and this particular call returns 0, and from this call we'll get a subsequence ea. So we'll return 2 from here, and finally we'll get 2 and 2 from both left and right calls, and we'll take the maximum of both calls, and finally answer would be 2. So in this case, our longest common subsequence would be ea, whose length would be 2. So in this way, we'll tackle this problem, and let's try to code this approach and submit this approach. So this is the code for the approach we have discussed through our recursive tree. So initially I've taken the length of these two strings. I have called the longest common subsequence function by sending both the sizes and string, and finally using this length from the string's length and adding it and returning from the main function. So let's see the longest common subsequence function. I've return the base case where if any of the pointer goes out of the string's length, will return 0. If the characters matches, we'll move these both pointers parallelly, and if does not, we'll either move I pointer forward or the j pointer forward, and we'll take the maximum of these two. So let's submit this code. As you can see, it gives time limit exited as we are using recursive calls and a particular state is being called again and again. So to optimize it, we'll memorize this particular recursion. So this is the code for the optimized approach. We have memorized the recursive calls and we have stored in a form of 2D vector as these two particular parameters are being changed for every particular call. And if a particular call which is being called is already being calculated, we'll directly return this value, or else we'll store that particular value in this way. So let's compile and run this particular approach and check whether it gets submitted or not. It's working now. Let's submit. As you can see, this problem got submitted successfully. So in this way, we have optimized the approach by using memorization in our recursive code. So this is it, guys. I hope you like this video and explanation. If so, please give it a like, share with your friends, and subscribe to my channel. I'll see you in the next one. Thank you.